see from behind. Is it clear, Anushka? Okay.
Get ready.
On your screen, man.
Wow, what is that?
And it's independent. Garrett?
Question is still there. You can see the question.
Why the heck? There isn't even a question here, it's just 4 different colors. I don't know.
You.
There's a gap.
Oh, sorry.
It's a lot to see.
Come on, Sim, answer the question.
Okay.
If you miss the question, it's still at the top.
Where's the top?
I didn't see the
No.
Top there.
That's a
White box
lightning smart.
with text on it. Not having mine.
There's one person that hasn't answered.
Isn't it probably
Can
possible?
I change my answer?
No,
No, no, it's all
there's 19 people in the room.
That's what I wanted to guess.
I got it 100. Who got it right?
I'm tired of it.
Okay, six
Who the heck
seconds.
chose green?
Next. Ready?
Wait,
I chose
who got 6?
We'll see that.
No,
It's not
6 people got it
people,
correct.
but-
I know that.
What dummy chose green?
We don't know. Alright. Next one.
So far,
Tell you that.
who is this? Okay. Now next question.
Well done, Harvika.
Thank you.
Yeah, good guess, Arthur.
Oh, I know this. Yes.
If you want to see, still there's the question, right? So you can still see.
Please be pure genius.
What is it?
Oh my gosh, oh my
It's
gosh.
individual work, so please do it.
What
Did you
You put the wrong answer, didn't you?
Did you seriously? Did you? Oh my God!
Oh my God, it's wrong. It's okay.
What happened? It's a circle.
แต่เห็นแล้วนึกออกมาเกิดไง
Good job.
I copied some and I got it wrong.
I didn't see carbon.
6 minutes.
This time it's only 6.
It was blue.
I'm not. I'm typing Yahoo.
Poor guy.
Logan, what do you?
Oh!
Joey is the highest sub.
And who's this? 370.
Boom, is that you? 378?
Okay, I said you could
Put your proper names. Hugo.
How's it looking?
Okay,
Read it
yes.
out. Okay, ready for next question?
Yeah.
Oh, I know this. Easy.
The accurate volume of solution generally is this PP, right? And as a filler, you can use either this one, and you'll be doing like this activity in a while. So basically, you can just press this one, and that goes here. Whoa, right?
Whoa.
And then if you want to like take water out of a container, you can just press this one, so water level will come up. And generally, it comes as 10 ml or 25 ml. So this one, the one that I have is 10 ml, and there is a mark. If you take this pipette, you can see there will be a mark, right? So you can fill all the way up to here, and if you fill more than the mark, then you can also read it. So there is, if you're using this one particularly, so one, that would like, if you press this one, it will salt the water up or give the solution, and then there is one written E, that's going to water. So you can just put it the mark, right? And you also know what you have to measure when you like how you have to measure the exact one. So there is a mark over here. Okay. And instead of using this, we can also use this filler. So this also basically goes this way. This is completely easier. And then when you press this one, so if you have to press this one, you leave the liquid, you can just press this one. Alright, so this is how you can use PP. So when do you use PP? If you want to deliver accurate amount or accurate volume of solution. Similarly, we have another apparatus called burette. Right? This is also to measure the accurate volume of solution added. So if you have to add the solution, you fill this burette, and you might have noticed here there is a stand. So this is how you can first fill using funnel, and you can fill water or any solution up to the level, and then you can fill this into the container, right? And the one tricky part with this would be unlike the other devices or other apparatus, the reading starts from here, right? It's 0 here, so you generally fill up to here, and you can actually start collecting or release the liquid or solution from here, and see like mark and then, and you can close it down this way. So if you want to release liquid from here or solution from here, make sure like it goes this way to release, and you can just make T, remember T to cut, right? So that's how we can stop, right? And you'll be doing some practice how to measure, how to use this pipette and burette today. And another apparatus here is volumetric flask. I'll bring volumetric flask in a while. So volumetric flask also come in different size. So generally this is the shape of volumetric flask, and depending on which volumetric flask you're using, we use volumetric flask to make up the accurate volume of solution. For example, if I want to make say 250 ml of 0.5 molar, let's say sodium hydroxide solution, then we generally use volumetric flask to make this solution, right? Can you do calculation and find out like how do you make 250 ml of 0.5 molar in your solution? I hope you remember the formula for concentration, right? So if I want to make a solution of 0.5,
I think we get time today, next lesson probably. Another half an hour left.
Will the lab books be graded by this? The lab books will be graded by
can you measure the last one? Yeah. If you look at your packet, at the bottom, you have the same diagram. Could you please write in the reading here? First page of the packet, you have the same diagram. You have to measure what would be the reading of all of this. And remember, when you're using this burette, the reading starts like 1 at the top and it goes increasing downward. So it is slightly different.
So the best first one is 0.
Now just think, what do you think?
Negative. How can the volume be? It's a
And
beautiful.
we'll talk about this. Okay, what do you think you write? And then we'll talk.
It's a beautiful.
It's a burette. And remember in burette, reading starts 0 at the top and it keeps increasing.
Wait, so you get from the bottom or the top?
You get from the top. Okay, I think everyone is clear, right? Burette, it starts with the top at 0 and increases downward. Okay, hopefully by this time everyone must have done. Okay, I know it's really hard for you to see from that distance, but you all have got that on your packet. Do you see this lower meniscus here is above the 0 line? So can you give a measurement for this one? So make sure whenever you do titration, you don't want to have your liquid above this 0 level, right? Because we'll be using burette in maybe like after 2-3 classes, because you have to do like lab activity based on titration, and you'll be using this burette. So one of the things to consider is do not have liquid above the level of 0, right? So you always want to make the level starting from 0 so that you can take the exact measurement.
So-
Because there's no way you can measure what's the volume right here.
volume, right?
There is definitely volume, but we don't know how much of that, right? And if you look at this one, as I said, 0 is here, 1 is here, 2 is here, right? So it goes downward this way. So what is the reading here? If you look at this, 2 is, you can see it is 2 is down there. There is like half mark. What do you think? What is the measurement here? The second one,
1.2.
1.1.
indicator. It will turn into pink color. So this is how, with the help of that color change, which is because of the indicator, we know now reaction is over. Is it clear for everyone? Okay, so now let's see what happens here. And then you have to do some calculation to find concentration of unknown HCl, and we'll do that. you need to understand like few terminology here. Equivalent point. So what is equivalent point? The point at which chemically equivalent amount of titrant and sample have reacted. Usually an indicator is used to detect the endpoint. So as I said here, it's 1-to-1 ratio, right? It is 1-to-1 ratio. So same amount of HCl. Okay, if you know like amount or number of moles of HCl, you need exact same amount of NaOH here, right? So when they will react to each other, that is called the equivalent point, and that will be indicated by indicator. Okay. Similarly, you can see endpoint. So during titration, endpoint the point at which indicator changes the color is called endpoint. Okay. So indicator, endpoint. So basically, as I said earlier here, the moment when there is more NaOH, it will change into color. That's how we know that reaction is over, and that's called endpoint. Is it clear? And you guys need to understand all of this terminology. Okay? I would say this in the Google Classroom. You can again review it, but make sure when you come next class, you need to know all of this terminology. And you'll be using this in lab work that we'll do next week. Is it clear? Anyone has any questions so far? If you have, feel free to ask me, because this is a little bit challenging concept to understand.
So, Mr. So we did that to find out
We haven't done the calculation yet.
the molarity of the whole thing, right?
Yeah, go ahead.
If the molarity of the whole thing, if it's the NaOH and the HCl that's mixed, right? But how can you sure the molarity will be like constant when it's changed into a base?
No, see, we are not looking at this one. So when it overall when solution turns to basic color, their indicator will change the color, right? But we know how much of base is being used, and we know concentration of NaOH. So this is standard solution. We know concentration, right? So we start at one point, and we measure how much of this NaOH is actually used to neutralize this reaction.
And
so
then
we have volume and we have concentration of this one.
So when the equivalent point is reached, when the end point is reached, we stop and then
Yeah, we stop there because once you see the color change,
is the indicator. The indicator starts off colorless because the acid is in the conical flask. Base is added in from the burette, which turns the indicator pink. As you near the endpoint, the pink color becomes more and more persistent.
No flash up, go away.
You have reached the endpoint when one drop from the burette turns the solution pink permanently.
Beautiful.
so you will be doing these activities. And one of the important thing to notice here, if you have noticed in the beginning, when person is dropped anywhere, it turned into pink color, but after seeking it disappeared. Right? So endpoint is the point where the pink color is persistently last there. Like it has to be like persistent there. Then only that's the endpoint. But as you get closer to the endpoint, even one drop of base can change the color. So once you reach to that point, you start to drop. You start to pour sodium hydroxide drop by drop, and you have to be very. And if you're trying to use this one, how does it work? Is
It has a
yes.
Squeeze.
So you can squeeze this one, and then there is one written S and one E. So what I'll do is,
Glory. That's a cheap place.
and this one is the graduated pipette, which has been like reading for 0, 1 and all. But most of the time you'll be using another one. So this is already has gone above the level of 0. So using this, you can pop, and right now it is at 0 level, and this is 5 ml pipette. And I can transfer this into this one. Yes. So yeah. Okay. Now one important thing. Once I pour, you might also still say like some solution is still here, right? And people might try to like blow by using this, and they try to blow to get all of this solution into this container.
No.
Okay, do not do this one because they are always designed, and when they design, they always consider this part. So there will be some liquid or solution always left over in this one. So never try to blow so that you measure 5 ml and there is still like some liquid left over. Okay, they are always designed in that way. All right, so do not do that. And also, it's not safe to blow or using your mouth.
You can use the finger blower.
But we will not do this because it is always designed in that way. So there will always be some left over. Okay, so I hope in a while you can practice how to use pipette. And this is burette. And whenever you use burette, you have to consider one more thing also. So I'm going to show a video in a while. Make sure like if I'm filling liquid or base into it, the basic solution, first of all you have to make sure to rinse this one. Because what happens if there is some liquid already here and if you use a known concentration of liquid or known concentration of base into it, what happens?
Concentration.
So say I clean this one, right? And after cleaning this also, it might have some water droplet in it. And if I use a known concentration or known solution or standard solution of base into it, and if it already has some water droplets in it, what happens to the concentration? It changes, right? That will not be the accurate concentration. That's why to avoid that, what you do is you first fill a little bit of base in it and make sure like it is always sewn to the sink, and you have to rinse this one, right? And once you rinse, then only you fill it. Does it make sense? So you have to make sure to do that. But for today, I'll just use this, and also make sure right now how is it? If you look at this one, open, right? So you have to close it. And whenever you do an activity or lab, make sure some of this doesn't work very well. So make sure to check if it works or not. And another good idea would be to use funnel. Alright, so now if you look at this one, the level has gone above 0, right? The level has gone above 0. What I'll do is, first of all, I'll just, and I hope you know all of these instruments, right? What is this? Stand. What is this one? What is it called?
Crucible.
Crucible. Seriously, what is it called? Clamp. And some of the clamp